Alright, hi guys. This is a video on inequalities, and it's a beginner video for chapter 9. I just kind of want to go through some basic notation, things that you should already know, but maybe I'm just jogging some memories for you. Inequalities are different symbols that we use in math. The most typical inequality that you all know is the equal sign, when two things are equal to each other. That's an inequality. But this chapter we're going to branch out a little bit because we understand the equal sign. It makes a lot of sense to us. We're going to branch out into these ones, these symbols, which I know you've seen before. We've got the greater than and the less than, and the greater than, less than, equal to symbols. And all 5 of these, when you combine them, are different symbols we can use to write equations for lines, parabolas, all the different things we've been doing in class. So my focus is going to be kind of on these 4. These are a little bit more newer, the greater than, less than symbols, and I want to show you kind of just the basics, just to kind of practice. So let's say I had 2 numbers, 7 and 12. Common sense tells us that 12 is the bigger number, so when I go to draw my symbol, I'm going to draw it like this. 7 is less than 12. Notice that this big opening right here is pointed towards the 12. So there's all these funny little ways you can try and remember this. I've heard teachers come up with things like it looks like it's an alligator mouth and it's eating the 12. The 12's the bigger number. You want to eat the bigger food. I don't know. I've even seen teachers do things where they draw little teeth inside of here like, look, it's eating the 12. Remember it however you want. As long as it sticks in your head, I guess. Whatever works, works, right? So like, let's say I gave you the number -4 and I gave you 0. What number's bigger, a 0 or a -4? 4 looks like a bigger number, but it's negative. In reality, 0 is the bigger number. So I'm going to point the big opening towards the 0. What about -3 and -10? What's bigger between those two? Most people think it's the 10, but it's really the -3. I'd rather have in my bank account -$3 rather than -$10 when you think about it. So, this chapter, we're hoping you already know a little bit about greater than, less than symbols, and we're going to get into what happens when I throw a variable in there. So I throw in an x. What if I told you x was less than the number 3? Think about all the answers x could be. Remember, x is a mystery number. It has to be less than 3, so x could be 2, 1, 0, -1, -2, -3. I probably could keep going forever here. Anything smaller. Could x be 5? No, because 5 is bigger. So it's got to be smaller numbers. Anything up to even like 2.99999 is okay. I just can't have it be 3, 4, 5, 6, 7 bigger numbers. So one of the ways we show that is we use a number line to kind of describe it. So let's put 3 on a number line. Let's say 0 is here. We went 1, 2, 3. And I'll put a few other numbers on here. One of the things I've seen people do is they'll go to the number line and they'll find 3. And a lot of times, like in our text, we call that the boundary point. 3 is our boundary. X is anything less than 3, so 3 is kind of the edge, it's the boundary. Anything smaller goes this direction, so I'm going to shade it in with a color here. And these are all smaller values, and it's just going to keep on going towards the smaller numbers. I'm going to leave 3 empty because there's not an equal sign in this problem. If there had been an equal sign, I could have shaded in the 3 and not left it as an empty hole, but x has to be smaller than 3. It can't be equal to 3. So it's going to be an empty hole. If I change this problem just slightly, let's say I did this. What if I had x is greater than or equal to -2? So -2 is my boundary. So I'm going to make up a number line here. Put on 0. Put on some numbers. And I've got to make sure I label -2 on here. And I now know x is greater than -2, so it's bigger numbers like 1, 2, 3, 4, 5, all those kind of numbers. Nothing smaller. So I'm going to circle my boundary, and I'm going to shade all the numbers that are bigger than -2, all of these numbers. going this direction. The actual value for -2, we have an equal sign here. I'm going to change the color of it. So x can equal -2. It's anything equal to it or bigger. So anything equal to it means I can fill this in and make it a solid point, a solid boundary. Right, solid there. So if there's an equal sign at the bottom, fill it in, make it a solid point. If the equal sign hadn't been there, I would have left it as an empty hole, basically. So could you think backwards on these? Could I make up a number line, put some numbers on it? So here's a bunch of 1, 2, 3, 4, 5s, -1, -2, -3, -4. And on this number line, I've already come up with an answer. I've said that 4 is my boundary. I've got it circled, and I've got it shaded going this direction. Could you go back and write what the inequality was for this number line to get this answer? It'd be pretty easy if you think about it. We know that the boundary is 4, and we have all these x values, all these numbers shaded. X, is it the bigger numbers or the smaller numbers? It's the bigger numbers. So it gets the big opening, or the alligator's eating it, however you want to think about it. And do I need an equal sign? Sure I do. There's a solid hole right there, a solid dot, point. So x is greater than or equal to 4. And that would be my solution. That would be my inequality to match the number line. So you want to have a good understanding. I have seen some people really struggle with one type of number line that I want to show you. And this will be kind of the end of our first video. And that is, what if I have a number line with more than one boundary on it? So for instance, I put on all these numbers. Sorry, it's not very even on here, but you get the idea. And maybe I have a boundary at 3 and maybe at -2 over here. And it ends up looking like this. Somebody's gone onto this number line, has circled 3, has circled -2, and shaded in between here. How are you going to write an inequality for that thing? Now I've got 2 boundaries to deal with. X, I call this a sandwich problem. X is sandwiched in the middle. It's all the numbers between -2 to 3. So what I'm going to do is I'm going to write down x, and I'm going to sandwich it between -2 and 3. X is bigger than all the -2 values, but smaller than all the 3 values. So it's smaller than the 3. It's bigger than the -2. Do either one of these need an equal sign? The -2 does, because it has a solid point. Because this is solid, right there, I gotta have my equal sign. Because this is empty, right there, no equal sign with the 3. And that is my inequality. So it's not officially called the sandwich problem or anything like that, but I just always remember, like, here's my 2 boundaries. X is stuck in the middle, so make sure when you write your inequality you put x in the middle and you just figure out those symbols, what direction to point them. Work on your greater than, less than skills, like memorizing the symbols and kind of getting them down. And stay tuned for more videos, because we're going to make these get much more difficult here soon. Hope this helps. Thanks.